So hopefully you found in question letter D that the structure itself gets really repetitive really quickly and that it's easy to predict. The initial value is 2, so we know in our equation the first number we'll write there is a 2 because that's our initial. The subsequent term or next term is 7 less than the term before it. Less than would mean subtracting, so this means we have a minus sign. And since the value of that adder is 7, we know that our equation will end up having a minus 7n. So putting the pieces together hopefully makes it relatively straightforward to understand that every arithmetic equation really just has those two parts, the initial value and the adder. Sometimes people ask, Herbert, how do I know which is which? How do I know which one is the initial and which one is the adder? The easiest way to know that is to look for the n. The adder is always the one attached to the n. So as soon as you see that, that kind of tips you off. Now the reason I'm saying that is because if you look at question letter E, you'll have another equation given to you, and this time we're kind of thinking backwards. Now we need to be able to figure out what the information that they're trying to tell us is if all they're giving me is that equation. So take a look at letter E for a second. If you can, challenge yourself. Stop this video and try to do question E parts 1 through 4 by yourself. You can always turn the video back on and check your answers along with me, or you can check the answer key and skip this video altogether. But if you feel like you understand now how these arithmetic equations work, you don't have to keep watching. I'll do this example in case you're still feeling a little bit rusty, but if you feel like you understand it, definitely feel free to skip around and do as many of these as you want to by yourself. For those who feel like we need a bit more structure, let's do a little bit of comparing the equation to letter E and the equation that we've kind of worked with and gotten familiar with in letters C and D. If you kind of compare their structures, notice there's once again a number with an n and a number without an n. And if you're saying, I don't know, Herbert, I don't see a number with the n. Remember, every variable has a number before it. We don't necessarily see it printed there, but this n, and any variable by itself always has an invisible 1 next to it. So if it helps to put that 1 there, definitely feel free to do so. Now let's think for a moment. Based on what we just mentioned, the adder is always the number that's attached to the n. So if 1 is the number attached to the n, that must mean 1 is the adder. So that makes sense. We must be talking about a pattern that is adding 1. Now, by default then, the other number must be the initial value. So that's the nice thing about only having 2 numbers to worry about, is that if you know the adder, the other one, by default, is automatically the initial value. So this is telling us automatically that the initial value must be -3. We know it as soon as we see it. It's the number that's not attached to n. Now, if I interpret the effect of this adder again, I'll say the adder of +1 means that this sequence is going to add 1. So if you want to think of a table, and they give us a table in part 3 here, we can think of it this way. The initial value, which is the 0 term, is going to be -3. And the next number in the pattern requires me to add 1. So -3 plus 1 would give me the next number in the table. That's -2. If I add 1 again, I'd get the next number. Add 1 again, I get the next number. Keep adding 1, and I'll get all of the next numbers as I go. So you can tell that the adder is just telling us what to do to get to the next values. By default, when you think about this vocabulary then, we must be increasing if we are adding something. Decreasing would be if we're subtracting something. So this pattern must be increasing by 1 because we are adding 1 every time we want to create a new spot in the table. So, just to summarize, the initial kind of tells you where to begin, and the adder tells you what to do next. That's kind of the general breakdown. Initial tells you where to start, adder tells you what to do next. So, the last thing that I want to make sure you understand about these equations is in part 4 here. Generally speaking, what does n represent? As a reminder, when n is 0, we call that the initial value. When n is 1, we call that the first term. When n is 2, we call that the second term. When n is 3, we call that the third term. and so on and so forth. And I wrote the word fourth, pun. So n just kind of tells you which number in the sequence we're talking about, or which spot in the sequence we're referring to. So if I said check out the table, go to n equals 3, you'd say, oh, the third term. If I said check out your table, go to n equals 1, oh, she means the first term. Check out your table, go to n equals 0, oh, that's the initial value. So it's just kind of a code. N is sort of a code that tells you where to go in the table. You'll definitely see me use tables a lot in this chapter because n is really useful when you have a table. N just tells you where to go. Now that you've seen how arithmetic sequences work, that arithmetics have an initial value and an adder, the challenge I want to pose next is, what do you do when it's geometric? What do you do when it multiplies? If you feel confident enough that you can handle the geometric or the multiplying patterns given only what you've seen here, then you don't have to watch the next set of videos. You can simply move right through on your own. If you feel like you need the continued structure, then keep watching, but make that judgment call for yourself. Between now and the time you think about the next video, do you need them? And if so, we'll go through it together via video. And if you don't need it, then just open up a tab with the answer key and start working through on your own. Make that decision for yourself based on what you feel is best for you.